everybody. In this video, we're going to be talking about decimals and how to introduce decimals to your students in a way that will help them conceptually understand what decimals mean. So the big idea of decimals is that they're a special type of fraction that extends our place value system. So when you're first introducing this to your students, you can relate it to stuff that they already know. So you can say, in our base 10 system, with whole numbers, if you have 10 ones and you put them together, you have a 10 block. And if you have 10 blocks together, it makes 100. If you put 10 hundreds together, it makes 1,000 and so forth. And then you can ask them, what happens if I break up 1,000 into 10 pieces? Well, that makes 100. What happens if I break up 100 into 10 pieces? Well, that makes a 10. If I split up a 10 into 10 pieces, that makes a 1. And so then you can say, well, what happens if I take a 1 and I split that up into 10 pieces? And you can show this visually if you have two sets of base 10 blocks, because a very common one that's often used is one like this, where all of the blocks are different colors. But you can buy base 10 block systems that have all the blocks the same color. And if you do that and you match the color with the unit blocks, then you can say, okay, let's imagine that one of these unit blocks, we're going to zoom in on it, and that's going to be this block. And we say, okay, well, if we take that block and we cut that up into 10 pieces, well, that means that that's going to be our next place value. And we call that our 1/10 place value, because if we split it up into 10 pieces, the number of pieces in the whole is just 10. And so that's why we have a 10 in the denominator of our fraction. And it's called the 1/10 place value, but you can have multiple tenths, like you might have 5/10 or 6/10 or 7/10. But the place value is just called the tenths place value. And then you say, okay, so we have one of these tenths that is one full block split up into 10 pieces. Well, what happens if I split this one up into 10 pieces? Well, in that case, I'm going to have my next place value, and we call it the 100th place value, because if you imagine one of those pieces, which is basically like a 10 rod if you were talking about whole numbers, but in this case, it's going to be our 1/100th rod. Because there's 100 of those rods in a full unit. And so that's our next place value. And then if you split that up into 10 pieces, well, then you're going to have these unit pieces, and those unit pieces have 1,000 of them within a whole unit. And so that's why this is the thousands place. And then if you were to cut that one up into 10 pieces, then you'd have 10,000 pieces in a whole, and so on and so forth. And by this point, your students should be able to see the pattern that basically, you go from tenths to hundredths to thousandths. So the next one would be 10,000ths and 100,000ths and so on and so forth. So that's the basic idea of what decimals are. And when I'm explaining it to students, I usually like to introduce the decimal point as the separation between the whole numbers and the fraction numbers. Because this can really help when you're ordering fractions, because you can almost think about the whole number part as being one number and the fraction part as being another number. And so that's the idea of decimal place value. And when we're working with decimals, we can write them in what's called expanded form. So expanded form is basically taking each number or each digit in the number and multiplying by its place value. So since the number 2 is in the tens place value, because remember the decimal point separates the whole numbers from the fraction numbers. So if I just look at the whole number part, that's the number 25. And the 2, it means that I have 2 tens. Then the 5 in the ones place means I have 5 ones. And then when I look at the fractional part, well, a 4 in the tenths place means that I have 4 tenths. An 8 in the hundredths place means I have 8 100ths, and a 9 in the thousands is 9 1,000ths. You can also write expanded form like this. So you could say this is the same as 20 plus 5 plus 4 tenths plus 8 hundredths plus 9 thousandths. So it's basically just like simplifying all of these like multiplication facts. So I guess this would be a semi-simplified expanded form. But putting it in this form can be really helpful for putting decimals into fraction form. Because if you think about it in this way, then you can say, okay, well, it's not too hard to figure out what the whole number part should be because I can just add the two whole numbers together, and that would be 25. But if I look at the fractions, in order to add fractions together, they all have to have common denominators. And in this case, we have tenths and hundredths and thousandths, and none of those are the same, so we can't add them together. But what we could do is we could make it so they do have common denominators. And the good thing about decimals is it's always really easy to find common denominators because you just multiply by powers of 10. So if we look at these three numbers, well, the least common multiple between those three numbers is going to be 1,000 because powers of 10 are also multiples of each other. And so I'd say, okay, well, if I want to make 10 into 1,000, well, I would need to multiply the bottom by 100, and to keep the fraction equivalent, I would need to multiply the top by 100 as well, which means that 4 tenths is equivalent to 400 thousandths. And then if I think about 8 hundredths and I want to convert that into thousandths, well, in this case, I'll just multiply by 10 on the top and the bottom, which tells me that 8 hundredths is 80 thousandths. And this makes sense because the hundredths, if we think about the base 10 blocks, are basically like those 10 rods. And 8 of those 10 rods is the same thing as 80 of the little teeny individual blocks. And so if you write it like that, now that they all have common denominators, you can add them all together. And you can say that this is 489 thousandths. And so this would be a mixed number form for the number 25 and 489 thousandths. And notice how the wording of reading decimals works. So basically what you do is you describe the name of the whole number, and then you use the word "and" to represent the decimal point. So it's important that you don't use the word "and" when you're describing your whole number. Like you wouldn't want to say, like if it was 125, you wouldn't want to say it's 125 because when you're writing out decimals in word form, the word "and" always represents the decimal point. And then when we look at the fractional part, we have 489 thousandths. So this thousandths is because our last place value will always be the least common multiple when you find common denominators and add the fractions together. So a lot of times, once your students get used to this, they may not necessarily have to write out this whole expanded form, but they may just be able to go straight to this because they'll realize, well, the last place value is the thousandths place value, and the number of thousandths I would have would be 489 because of the way that the place value system works. So that's the fractional form and the word form of decimals. You can also write this in an improper fraction form. So rather than saying you have 25 and 489 thousandths, you could say that you have 25,489 thousandths because 25 wholes would be 25,000 thousandths. So you can also write it like this or like this, depending on which one is most useful. But I usually like going with this way because it makes it easier to describe it in word form. So when you have a fraction and you want to represent it as a decimal, basically what you're trying to do is you're trying to get the denominator of the fraction to be a power of 10. And one of the ways that you can do this is by finding the prime factorization of the existing denominator. So for example, if I have 1250, I could say, well, I know this is divisible by 10 because it ends in a 0, and I'd have 125. 125 ends in a 5, so I know I can divide by 5, and when I do that, I get 25. 5 is prime, but 25 can factor into 5 times 5, and 10 can factor into 2 times 5. And so if we write out the prime factorization of this denominator, we have 2 times 5 times 5 times 5 times 5. And then we have the number 7 on top. So if I want this to be a decimal, I need to have powers of 10 in the denominator of my fraction. So I know that 2 times 5 equals 10, but 5 times 5 times 5 does not have powers of 10 because they would need to be multiplied by 2's in order to equal 10. So the way that we're going to change this denominator so that it has a denominator that has a power of 10 is we're going to multiply by 3 2's in the denominator, because those extra 2's, when you multiply them by the 5's, will make 10's, and then you'll have a power of 10 in the denominator. So if we multiply the top by this as well, 2 times 2 times 2 is 8, and 7 times 8 is 56. And so I'll have 56 over 10 times 10 times 10 times 10, 4 times. So that will be the number 10,000. And once you have a power of 10 in the denominator, then you can write it as a decimal and you can say, okay, well, where is the 10,000ths place value? Well, this one is the tenths, this one is the hundredths, this is the thousandths, and this is the 10,000ths. So we say, okay, well, if I have 56 10,000ths, well, that means that I have 6 of my 10,000ths, and then I have 50 of them, which I could also think of as 5,000ths. And then I don't have any hundredths or any tenths. And so this decimal right here would be the decimal version of this fraction here. So why don't you guys pause this video and try the second one on your own and then restart it to see how I would solve it. Okay, so on this one, I'm going to find the prime factorization of 40. So we know 40 is 4 times 10, and 4 is 2 times 2, 10 is 2 times 5, and 2 and 5 are both prime numbers. And so the prime factorization of 40 would be 2 times 2 times 2 times 5, and then I would have a 3 on the top. And if I want to make it so that I have a power of 10 in the denominator, I'm going to multiply by 2 5's, because this 2 times 5 will equal 10, but these two 2's need some 5's in order to have them multiply out to 10. So if I multiply the bottom of my fraction by 5 times 5, I also need to multiply the top. And 5 times 5 is 25. If I multiply that by 3, that's 75. And so I get 75 over 10 times itself 3 times. So that will be the number 1,000. And once you have a power of 10 in the denominator, then you just figure out where that place value is. And you say, okay, well, this is the tenths, this is the hundredths, this is the thousandths. And if I have 75 thousandths, I'll have 5 thousandths, 7 hundredths, and 0 tenths. And so this would be the decimal form of this fraction. Now, this only works if you only have factors of 2 and 5. If you have other prime factors, like if you have a 3 in your prime factorization of the denominator, or a 7 or something like that, then you actually won't be able to express it as a terminating decimal, meaning that it's a decimal that stops and doesn't go on forever. Like, for example, the fraction 1/3, if you write it as a decimal, it actually equals 0.3333333333333 forever. And basically, anytime you have any factor that is not 2 or 5 in the denominator of your fraction, it will be a repeating decimal. So we'll talk more about repeating decimals in a later lesson. But one of the theorems in this lesson is that if you have a fraction, a over b, that's in simplest form. So it is important that it's reduced and in simplest form. But it will have a terminating decimal form if and only if the prime factorization of the denominator b contains only 2's and or 5's. So if it has any other prime numbers in the prime factorization of the denominator, then it will have a repeating decimal form, but it will not have a terminating decimal form. So that's everything I wanted to say in this video about decimals. If you have any questions, let me know.